So this timing of rainfall, both on like a seasonal time scale and shorter time scale, is probably going to matter. Other features that are going to matter a lot for thinking about what temperatures you might get out of a system and things to pay attention to are things like ground cover and radiant heating of soil. So this was work by Jay Quaid and others in 2013. They looked at a number of mostly arid soils from regions in Arizona and Tibet. All of them have relatively little ground cover, and one of the things that they noticed is they certainly tended to get a strong warm season bias, but what you would predict in terms of temperatures you would get sort of with this is modeled winter, mean annual, and warm season soil temperatures just based on sort of soil physics, soil temperature modeling. You would expect the biggest variation between those at the surface and kind of damping down to a mean annual temperature signal with depth in your soil profile. So if you were just getting a summertime seasonal formation, you'd expect all those data to plot here. And instead, they match best with that same sort of curved profile with soil depth, but offset by about 7 degrees. And their argument for this is you're basically seeing, you are forming these things during the summer, and you're basically seeing a net effect of your seasonal bias plus extra heating, radiative heating of the soil, because you don't have a lot of ground cover, you don't have a lot of shade. So there's definitely potential to amplify your signal depending on what kind of ground cover you get, what aspect your soils are at, things like that. Okay. And you can also, this was a follow-up study by the same group that the Peters et al. Study came out of, just to kind of think about scales of complexity. You can imagine also other ways to get an inversion of temperature profiles. So what you notice here is really warm temperatures. At this profile, this is about 2,000 meters elevation. So you'd right off the bat say, well, there's probably some warm season bias. You also notice that you're basically getting an inversion of temperature with depth. So if you were really getting a warm season bias, you would expect those warmest temperatures up at the top of the profile, as opposed to actually at the bottom. So their argument was you're ending up even within your soil profile of 2 different soil moisture regimes, essentially. So at these shallower profiles in this particular relatively arid environment, your moisture doesn't actually propagate very deeply into the soil. So the shallow settings, they get wetter, but they also dry out more quickly. And so they promote, at these shallow depths, carbonate precipitation probably right after these smaller scale rainfall events. And the effect of that rainfall is also to depress the temperature a little bit. So they argue you're ending up getting these sort of lower temperatures because you're getting formation right after a small scale event. These deeper depths don't notice those. Soil moisture stays a lot more even down there, so they're not noticing these precipitation events except for kind of the very biggest ones that soil moisture propagates to greater depths. So here, soil moisture is, at your shallow depths, soil moisture is probably controlling the actual timing of carbonate formation, whereas at the deeper depths, you're actually being driven more likely by temperature, and hence why they see this stronger warm season bias. So you can imagine this can get potentially complicated really quickly. So when we think about what we might do with that in the geologic record, the thing that it really hammers home to me is how important it is to really collecting your samples. We talk about this a lot, but with as much geologic context as you can get. So there are definitely paleopodologists out there in the world who you can work with, who help with a lot of the sort of general context of your samples. Are all indications, both qualitative and semi-quantitative, telling you that you're in a relatively arid soil? Are they telling you that you're in a semi-arid soil that's just highly seasonal? What kinds of grain sizes do you have? Do you have mechanisms? Are you talking about things that have formed in really fine-grained soils with a nice clay-rich BK horizon, which is going to definitely be different than, say, a gravelly soil with clasts, where you're going to have entirely different drainage patterns? All of those are probably going to matter for how you might interpret temperature. And we certainly haven't explored much at all what role microbes that we definitely know are in the soil might be playing with in terms of dictating carbonate formation. I know I'm getting close to running out of time, so I'll just spend the most time on soils because that's honestly where calibration work in the clump system has happened the most. When we think about lacustrine systems, People often think in terms of either authigenic carbonate that forms, so things like Whiting events, biogenic carbonate, how much of your carbonate is made up from that, and microbial carbonates as well, so things like stromatolites, thrombolites, and how that microbial activity might affect your clumped isotope system. So Whiting events, this is an example from Lake Michigan. You can kind of see the cloudiness forming. Typically, we're thinking about our levers on carbonate formation. The idea in this particular setting is it's being driven by increased temperature. So this particular lake, you have limestone as your base of the lake, so you have plenty of source for getting your fluid, your lake water carbonate saturated. And then when you go through your annual temperature cycles from seasons, once you hit that kind of critical temperature warmth, you'll get carbonate precipitating out of solution. So in that context, you can imagine you would end up with a really strong seasonal signal for any of this kind of micritic, inorganically precipitated carbonate. So this was used in paleo studies to argue for a summertime, you're basically getting summertime temperatures out of lake carbonate. Yeah?
What was the white on those aerial photos that's showing what?
That's the carbonate.
That's the carbon?
Yep. That's why they call them Whiting events. So you just have, you hit this, the idea is you kind of just hit this key point in, for sort of getting super saturated once you hit the right temperature, once you've had time to warm up, because your overall, carbonate, carbonate chemistry is all there. It's just getting the lever to kind of push you over to precipitate. And that's being largely driven by your seasonality of temperature. So once you get nice and warm in the summer, everything just sort of precipitates out of solution.